Hello, everyone. I'm the last speaker of the day, so I'm going to do my very best to not bore you and instead actually engage you with a story. My talk's not going to be heavily technical, but what I'm going to do instead is introduce you to the Inter-Blockchain Communication Protocol, which is the interoperability protocol that got its start in Cosmos and now connects over 115 chains and does 3 billion of asset transfer volume per month. So with that, if you have ever experienced a blockchain going down, maybe you were on it, maybe you were trading a meme coin and suddenly you couldn't because Solana was down, or Polygon ZKVM was down, or AVAX was down. This is something we see in an ecosystem that is reliant on a single monolithic chain. And when that happens, it means you also can't get your assets on or off the chain. So this clearly has implications for scalability and user experience, right? Over time, chains have gotten better at managing their downtime. I mean, I know Solana is infamous for their downtime, but they've gotten better at their uptime and increasing their TPS as well. But I'm going to talk about scalability today from the perspective of talking a little bit about Cosmos and the Interchain, a little bit about Ethereum, and then talking about how IBC enables scalability for heterogeneous blockchains, so blockchains across any ecosystem. First things first, Cosmos. So you've probably heard of Cosmos, 2021. The founding story of Cosmos was that a bunch of really smart guys got together in a room and they said, what if we could create a set of technology that would allow anybody to make a blockchain for whatever they wanted? You want to make a blockchain for your community, for your business, for your specific scientific use case, for you and your friends, you can do it. And they called this the Appchain thesis. Now, this really caught on. Cosmos, ever since 2020, 2021, more and more chains have started to use the technology, and Cosmos has changed from being Cosmos into the Interchain. The ecosystem expanded enough that they've actually taken it past just the Cosmos hub, the first and most famous chain, and given it a new name to encompass the creativity and the variety of chains that are within the ecosystem. And then we have Ethereum, also near and dear to my heart. I am a huge ETH maxi, don't tell the Cosmos people, please. But Ethereum, monolithic blockchain, very famous, layer one. Ethereum started to run into some challenges around scalability, transaction cost. It was a very secure system and had a lot of innovation happening on it, so a lot of retail end users wanted to use it. But over time, this became an issue around transaction cost. If you remember last cycle, last bull market, people started making jokes like, only whales can use ETH, you gotta already be rich to use ETH, right? Now, this issue became a very important one for folks in the Ethereum ecosystem to figure out. So they started to figure out how they can create scalability within Ethereum. And what we have today within Ethereum is we have an interconnected web of layer twos, roll-ups, all of which rely in some way on Ethereum, either directly or indirectly through a bunch of different methods. And this has, in itself, created a very, very large interconnected ecosystem of chains that do in some way link back to ETH. Now, in solving for scalability, the Ethereum developer community did reduce transaction costs. They did make transactions faster. There are so many more ways for users to transact directly with ETH or with L2s or rollups that are related to Ethereum. But at the same time, certain things are sacrificed. One of these things is seamless interoperability. I found this code to be extremely funny. This Twitter user said that they were bridging ETH from L2 to L1. It was scary AF. They explored Mantle L2. It was a 15+ day return trip. They had a 7-day wait for a challenge period and a 7-day wait for a promise period. Now, this, of course, is an inherent challenge when we're working with a hierarchical ecosystem, right? So what we have here basically is Ethereum today has a Cosmos problem. The problem is not Cosmos. We would like to be friends with Ethereum, but the problem is we have an ecosystem of all these chains who are all talking to each other all the time, but in the end, it's not always happening well. There's miscommunications, users are getting lost, their assets it's hard for them to get around, they're paying a bunch of money or they're losing money because they can't get their assets out in time, things like that. And so we have these two ecosystems now, right? On the right, we have Ethereum. This is a very simplified model. Obviously, you guys, Ethereum has many more than 4 chains that connect to it. And then on the left, we have Cosmos, or the Interchain, which is connected point to point. I talked a little bit at the beginning about how Cosmos's Appchain thesis came up. When these guys got together and thought, hey, let's let anybody who wants to make a blockchain for their use case, they realized they also needed to figure out a way to let all of these blockchains talk to each other, to seamlessly and easily communicate, and not just communicate and send tokens. Because they were like, why would we only let them send tokens if they can actually send any type of data? And so what the founders of Cosmos created is they created IBC, which is the Inter-Blockchain Communication Protocol. This is the protocol. I'm on this team. We're at the Interchain Foundation. And IBC as an interoperability protocol today connects 115 chains, does about $30 billion every 30 days in asset transfer volume, has about a 22-second time for packet delivery on average for Comet BFT consensus. And we are fortunate enough to have had 0 security exploits on the main protocol, which is quite exciting for us, knock on wood. I don't want to advertise this too much because it might come back to bite me in the butt later, but it is quite exciting, right? And the reason why I said Ethereum has a Cosmos problem is because the problem of the hierarchical ecosystem or the lack of communication or the miscommunication was something that the Cosmos founders had thought about when they decided to develop IBC. Because they said, hey, if we have all these different app chains, they need a seamless and uniform method to communicate. And that's why they invented IBC. Now, linking back IBC to the idea of scalability. IBC in itself is a generalized transport layer, which is basically a fancy way of saying it is a language that blockchains use to communicate. IBC is the letters of the alphabet. With that, a developer can make a sentence. Other blockchains can read and understand that sentence. IBC has a very rich feature set. Of course, it allows for token transfers. It also allows blockchains to send and receive any type of data as long as it is encoded in bytes, which means it's a general purpose message passing protocol, much like TCP/IP, which underlies the internet. In addition, with IBC, it allows a chain to read a counterparty state cross-chain through a feature called interchain queries. And with IBC, a chain can also write a counterparty state. We have a feature called interchain accounts that actually allows chains to do cross-chain account control, which in this way also creates scalability because suddenly chains are able to leverage other chains' block space in a very seamless and easy way, and in a way that is truly, I hate to say it, but it's also pretty fast. Moving next. Here we go. Now I'm going to talk to you about a few IBC-enabled products that you can play with today. This is just a few of them. There's literally hundreds out there, so I highly recommend that you look at them. The first is Noble. They are building liquidity infrastructure for USDC and real-world assets to bring them into the IBC network. They do about $1 billion every 30 days in IBC transfer volume, primarily with USDC. They've just announced they're also bringing Frax into the IBC ecosystem as well. And they are a huge conduit for the IBC network, bringing in all sorts of stablecoin liquidity into IBC. Another really interesting use case here is cross-chain liquid staking. Excuse me, guys, sorry, this aircon is blowing directly on my head. Okay, cross-chain liquid staking, that interchain accounts feature that I mentioned before that allows chains to write a counterparty state can allow you to do things like seamless cross-chain liquid staking. A user goes to the Stride chain, Stride front end, they deposit their asset from another chain. What Stride does on the back end is it actually uses the interchain accounts feature to seamlessly deposit their asset cross-chain for them, and then on the Stride blockchain mints them their LST. And all of this happens within the Stride front end. So they're connected to, of course, multiple chains, and a user can liquid stake across all of these chains just from Stride. Next, we have Celestia, which does data availability for rollups. They are fully scaling to bring many different rollup VMs into the IBC network. And then finally, for those NFT folks out there, cross-chain NFTs. Stargaze is a cross-chain NFT platform. Their NFTs are natively cross-chain through ICS 721, which is basically allows NFTs to be transferred over IBC. And they also have an interchain naming service. So if you're familiar with ENS domains, this is like that, except it is fully cross-chain and cross-chain native across IBC. So this is it, guys. Thank you very much. Enjoy the rest of your evening.